Hello, good afternoon to you. I'm Jason Lee, an associate professor at the School of Medicine at the National University of Singapore. My research interests are in fluid balance, thermoregulations, and often looking for strategies to enhance human performance, especially in the hot environments. So what will I be talking about in this short presentation? I've been given about 20 minutes or so. I hope I will impart some useful knowledge specific to nutritional strategies to optimize marathon performance, consumption of sufficient carbohydrates. I'll focus more on hydration. More is not necessarily better. I also talk about heat stress, that you don't need the temperature to be extremely hot. You appreciate a small increase in ambient temperature is enough to compromise your personal best intention in marathon race. And therefore, if you're looking for a PB, a personal best, then do not run the race in countries like Singapore. But not only you should seek to run a quality performance. I hope to impart some tips at the start of the presentation to allow you to run the race safely and to avoid the commonly known exertional illnesses associated with running a marathon race. Okay, I would like to assume that most of you have some fundamental knowledge on this topic, and therefore, as much as possible, I will direct you to relevant data acquired from these parts of the world, from Singapore, because that's where I'm operating from, so that the findings and therefore recommendations can be more specific. I call this marathon in China first boom, then quality, because we know as your nation, China in this case, becomes more affluent, right? There'll be more emphasis in public health. We know exercise is medicine. In fact, to be more accurate, I would call it exercise replaces medicines. Running is a popular physical activity. Not only the entry barrier is low, there is also this social elements that makes it so attractive. Marathon running for us runners is known to or perceived as the event, and therefore explains the boom in this past decade or so. While this exponential boom may not last forever, many, including you sitting in this lecture, are seeking to enhance the quality of the race. So it's no longer just participation. You want to do it well and you want to do it safe. So as I mentioned earlier, at the foremost, you should be aware that it's not just heat-related illnesses, fluid imbalance. There are also other possible exertional illnesses that come with marathon running if you're not careful. I have no time to elaborate, but you should be aware. This is a list of possible and common exertional illnesses from postural hypertension all the way to exertional rhabdomyolysis. Flash this slide, especially for those who are physicians or in the medical sectors, that is important to diagnose what is the cause of that collapse or incident before you treat. And because the symptoms are non-specific, so we cannot be sure until you diagnose properly. And also somebody in this case could be vomiting, unconscious and confused. It could be hyponatremic, or it could be because of heat stroke. So please bear that in mind. And specific to exercise-associated hyponatremia, this is the definition when blood sodium drops below 135 millimole acutely or within that 24 hours. And often This is caused by dilution, less so due to depletion, i.e. that there's a good chance that you overhydrate rather than to deplete them through excessive salt loss through your sweats. So now this is the first set of data I want to share, that between 135 and 145 millimoles per liter, blood sodium concentration is considered normal. Above 145, you're probably slightly dehydrated, and above 135, you'll be considered hyponatremic, probably due to overhydration. So surprise, surprise, most individuals who were admitted due to fluid imbalance issues were actually hyponatremic, possibly due to overhydration. In fact, most you could find that they are not due to fluid imbalance reasons, so do not assume it's always dehydration. And if there's anyone who was slightly dehydrated in this profiling exercise, there was only one. So most individuals are capable of overhydrating if we are not careful in over-advocating the importance of hydration. And this is one very sad case, non-marathon related. It was a game, it was a contest that this lady, Miss Strange, young lady that overhydrated and passed on subsequently. This is really very sad, but be careful, indirectly we are playing such a game in marathon races. So drink, but drink sensibly. And I want to highlight these risk factors, athlete related and event related. The more of these risk factors you fulfill, the chances or the probability of you incurring exercise-associated hyponatremia increases. So do take note of these factors, that while drinking is important, too much drinking is not good, and at times could be worse. These are some of the key physiological and nutritional demands of running a marathon in the heat. I'll touch on these three. I'll briefly, in my next slide, talk about energy availability, but I'll focus my talk on heat stress and fluid balance. So very quickly on energy availability, you probably heard carbo loading, and it's a very common and well-established strategy to enhance marathon performance. Basically, doing so, if you carbo load well, you can run at the optimal pace for a longer period of time before you slow down, you get tired. In well-trained runners, this has been done by tapering, training set about a week leading to the race, and ensuring carbohydrate intakes of about 10 grams per kg body mass each day for about 2 days prior to the race. You may be also aware that there's this notion of training with low glycogen stores to induce better training responses. I think there is room for that. For example, during selected low intensity sessions during your training phase. But certainly I wouldn't advocate it for competitions, i.e. no low glycogen stores for competition. That will not do you good. During the race, you can consume about 30 to 60 grams of carbohydrates per hour. Often this can be acquired through the sports drinks. You can also consider trialing up to about 90 grams of carbohydrates per hour from a mixture of carbohydrate drinks and concentrated gels, for example. I said trial because some of you might not be tolerable to concentration above 60 grams per hour. Some could. So in all, the 101 principle of sports nutrition, never try anything new on race day. So trial, practice them and see what works for you and what doesn't work for you during training, during practices, before you apply them at actual race events. Okay, now on heat stress hyperthermia. This is a very well-known experiment and clearly show that as you move from a hot to neutral and then to a cold environment depicted at 40 degrees Celsius, 20 degrees Celsius, and 3 degrees Celsius. In this case, they are testing endurance, means asking the participants to cycle to exhaustion. And clearly, when you're in a hot environment, you cannot last too long, and therefore you stop prematurely as compared to the neutral environment, and you do much better when you're in a cool environment. In this case, at 3 degrees Celsius, although the known temperature known for optimal marathon race is somewhere close about 10 degrees Celsius rather than 3, and definitely not 20 or 40 degrees Celsius. But not many are aware that even minute increase in temperature can do a damage. So here we perform an analysis based on data collected in Singapore, and we look at performance and heat illnesses. I want to focus you more on the performance data in this case. Now we term them in two categories, non-finishers and individual performance timing. Again, I will focus on the number of finishes. So here you could see on the x-axis, the temperature across 6 years were relatively minute, very minor. But as we line them out from a ascending order, you could see a very nice trend in terms of the number of finishes. So humans are actually more sensitive to environmental heat stress than we assumed. You could see just a small increase in ambient temperature, the overall number of finishes drop accordingly, and 1% denotes about 500 runners. And if you're observant on this graph on the left, it doesn't mean that when it's cooler, you can run faster too. In this case, there was actually a drop. It could be because when the environment is considered favorable from runners in tropics Singapore, some might overrun beyond their pace and therefore do not complete the race ideally in terms of the number of finishes. Even for well-trained individuals, you could see even a tighter range depicted here on the y-axis. And this depicts female and male elite runners. And with very slight increase in ambient temperature, their finishing time decreases accordingly. So you don't need drastic ambient temperature to do a damage to your marathon performance. A small increase in temperature is good enough for humans to sense the heat and therefore slow down accordingly. So we perform a series of profiling exercises. In this case, we asked the participants to swallow ingestible temperature capsules. And you can see this is a race, it's a half marathon. And as you see from this, each line here depicts an individual. A half marathon race, you could see a few individuals crossing what is normally known as a limit, where you get concern of exertional heat illness because runners get too hot. You see quite a few of them exceeded this threshold here. But as the race moved from one, and this is again another graph just to affirm that likewise, you see a few individuals who cross 40 degrees Celsius at half marathon. But as the race moved from half marathon to full marathon, actually, the concern of heat strain decreases because it makes a lot of sense, right? As you run far, you cannot run too hard. So in contrary to what many assume, the longer you run, the risk of heat stroke decreases. In fact, the risk of water intoxication might increase as you run longer because there's more time to consume fluid. And if in cases where you consume excessively, it poses a risk. But it doesn't mean that the longer you run, the risk of heat injury increases. And as we further extend the distance from full marathon to 56 kilometers, you could see that there are more individuals that fell below 40 degrees Celsius. So I just want to send across the message that heat illness is not a main concern in marathon races as compared to some of your shorter events like half marathon or even 10 kilometers. So next, on fluid balance, often we heard about dehydration. I really emphasize some information on overhydration. So a quick 101 of fluid balance. It's important to stay hydrated because we need to sweat well, because that is the main avenue of heat loss during exercise. And bear in mind, it is excessive dehydration that poses a risk to your performance and health. And it's not dehydration. 1 or 2% dehydration is okay. It's okay to finish a race lighter. Do not seek to maintain or in worse, put on body mass at the end of a race. But the problem is that there is significant variability in sweat rates. So do not adhere to common guidelines and take it wholesale. Work from those guidelines. Find what works for you. Because as you will see, we sweat very differently. And don't go away with the assumption, since we do not know how much we sweat and therefore we should just replace as much as possible. As I shown earlier, over drinking is equally bad, if not worse, because it can lead to exercise-associated hyponatremia. So here is a study we did, and even when we control for these 4 known factors that determine sweating, and every dot here depicts an individual, when we control relatively tight, because this is a group of individuals who ran a half marathon between 90 minutes and 2 hours. They were all from Singapore. We forced them to wear the same attire. The relative intensity was within a tight range, and of course, they ran in the same race. Even when these 4 conditions are largely controlled, you can see a huge variation in how much they sweat, and therefore one size clearly cannot fit all. I could talk so much about this graph. It's such a rich data set. We collected more than 2,000 participants across race distances in both males and females. But the key point I want to highlight is none of these individuals, when they get dehydrated, were presented unwell, and therefore acute dehydration is usually okay. And if we stick on to that -2% cutoff, we could see that close to 50% of these individuals finish the race more than -2% body mass. This is not a design study to look at performance, but in terms of health, I could say that they were okay. So excessive dehydration is acutely might not do much damage to health, possibly performance if you are excessively dehydrated. Let's run through some examples to see what it means to you when you talk about how much you should drink. Assuming you are 70 kg and you exercise for 2 hours and you sweat in the order of 1 liter per hour, and the commonly known guideline is not more than -2%, and that essentially means that in your case you sweat about 2 liters. That's about 2.9% body mass loss if you are 70 kg. And if it's -2%, you can afford to lose about 1.4, and therefore in real, you ought to drink over 2 hours 0.6 liters, and therefore 300 ml per hour. That sounds very sensible, very doable, and I think it's evidence-based. But what happens if you are a high sweater? And high sweaters are normally known with well-trained individuals. If you run through the same equation, now you might struggle a little bit, because when you sweat 2.6 liters, in this case over 2 hours, because you are high sweater, to replace 1.3 liters per hour becomes a little bit more difficult. And in a recent study, we found indeed in well-trained elite runners, You could see the timings in both males and females. They easily sweat above -2% body mass. You could see some even get close to 8% body mass. And these are individuals who finished the race well, they podium, and look at their marathon timing, for males, very fast, likewise for the females. So likewise, if you adjust their threshold, in this case, I'm just running an example. So maybe their tolerance is not -2%, it's probably at 4%. And then the recommendations, potentially could be much more acceptable, because it's all about understanding what is your personal threshold in terms of dehydration, and therefore hydrate accordingly. We also did another study and found that in well-trained athletes, in this case, if you appreciate 66 mL per minute per kg of VO2 max, 66, pretty fit, 3% body mass deficit, i.e. when we dehydrated them up to 3% body mass loss, there was no impact on their cardiovascular strength. So if you are fitter individuals, that is scope for you to probe, maybe you can tolerate a higher degree of dehydration and not stick to the commonly known -2% threshold. All right, I hope in this short presentation, I reinforced that running a marathon race optimally demands huge physiological demands. And the incidence of exertional heat stroke actually decreases when the race distance increases. Bear in mind there's still misconceptions in hydration recommendations, such as fluid loss during exercise. Must they be fully replaced to maintain your performance? I don't think so. Does drinking to match all of the sweat that you lost prevent heat illnesses? It's not evidence-based. And finally, the fluid required to induce positive physiological adaptations is often not achieved in actual races. So the question I would like to leave you to ponder is, are you looking for good physiological responses or a good marathon race? So bear in mind that a lot of the lab experiments might show very good physiological responses based on certain hydration recommendations. But from an athlete perspective, it's largely about good performance and not just good physiological responses. All right. Thank you so much for your attention. And I hope my talk is useful. All the best for your examinations. And thank you once again for your kind attention. And I hope to see you soon. Thank you.